This example, we're going to do a rectilinear motion example without t. So say we're given acceleration as a function of position instead of as a function of time. And we need to find the velocity as a function of position, and then the velocity at a certain position. And we're not given t. Then in that case, we need to use the differential relationship that does not have t. So the only one here, or if we remember, we've got v equals ds dt, or a equals dv dt equals d squared s dt squared equals v dv ds. Okay, so there's only one of these that doesn't have t in it, so we'll use that one. All right, so we have a equals v dv ds. So we separate and we get all the v stuff on one side and then the other stuff on the other side. So we'll get v dv equals a ds. Okay, so now these need to be integrated. So we'll integrate that side and that side. Okay, so then we have integral of v is going to be the v squared over 2 equals integral of a ds. So if we integrate all of that stuff, which we'll just write it over on the side, integral of 3 e to the negative s plus 1 plus 4 s cubed ds. Okay, so we integrate that. So this gives us negative 1/3 e to the negative s plus integral of 1 is going to be s plus 4s cubed is going to integrate to s to the 4, and then a plus constant. Okay, so to find what that constant is, we can just plug in the initial condition, v of 0 equals 0. So that gives us, so if v of 0 equals 0, then we'll just have the 0 squared over 2, which is 0, equals e to the negative 0 power is just 1, so negative 1/3, plus s is 0, plus s to the 4 is 0, plus c, which gives us that c equals positive 1/3 to balance that out. Okay, so putting all that in here, now this has a v squared over 2, so we need to take that 2 and multiply it over around the other side, and that'll give us the v squared, and then we take the square root to get v. So we'll have v equals, first we'll just write all the stuff from before. We'll say the 2 times negative 1/3 e to the negative 5 plus, sorry, that's not a negative 5, that's an s, plus s to the 4 plus this 1/3 from the c, and then all that has to be square rooted because the v was squared. So this equals v of s. Now, if we want to find v at s equals 9, like it asked there, then we just plug in 9 for all of that. So we'll say v of 9 equals square root, all this stuff will have 2 times negative 1/3 e to the negative 9 plus 9 plus 9 to the 4th power plus 1/3. And we plug all that into a calculator and we get 114.6. So that is v of 9. So basically what you do on problems like this, the problems without t, You have to remember that the integration is going to be a little bit different, and you're going to end up having, because you separate and integrate and you get the v and a dv, then you have to integrate and get the v squared over 2 and not just plain v. So it'll generally have a square root in your answer.